Warning: this video is intended for demonstration purposes only. Trying to duplicate the shown procedures may result in serious injury or even death.
Hi, in this video I will extract palladium and platinum from some of the best yielding multi-layer ceramic capacitors, the KM6 H90 made in USSR. I found these beauties hidden in an aluminium box from an unknown device lying in the corner of the scrap yard. I harvested 114 gram ceramic capacitors. To extract the precious metals, I decided to smelt the capacitors with lead and silver as before. I chose this path not only for being the fastest, but I also had the unique opportunity to test the recovery method efficiency, as all capacitors were of exactly the same type and with a certain yield. Before smelting, I incinerated the capacitors and separated the ceramics from the leads and the solder. I ground the ceramics in a coffee grinder equipped with a tungsten carbide blade. I weighed 28 grams of silver, which should be enough to lower the PGM's content of the final bead to under 25%. I mixed the silver beads with the ceramics powder. Then I added borax and mixed again. About 60 grams of litharge were also added and mixed with the rest of the charge. Finally, the charge was covered with sodium hydroxide. After preheating the scorification dish, I placed the charge and added about 200 grams of lead metal. Unfortunately, my cam's battery ran flat, so I'm missing the footage of the rest of the scorification process. What wasn't shot? I added more sodium hydroxide to produce nice runny melt. After mixing well, I lowered the temperature enough to solidify the slag above the molten metal. After ensuring there are no trapped metal beads in the solid slag layer, I poured the molten metal and left it to solidify. Then I cleaned the scorification dish from the slag and placed the now solid metal back in. Then I melted the metal once again and started oxidizing the lead. When the produced litharge was covering the molten metal, I was tipping the dish to one side, allowing the molten slag to flow out, revealing new metal surface for oxidation. This was repeated until the pool of molten metal stopped driving and froze into a solid bead. Following is the XRF analysis of the scorified bead. The results came out promising, although the lead percentage seemed a bit high, maybe due to the remaining, thin, slag layer covering the button. Time for math. I have button that weighs 38 grams, 14% of it is palladium, therefore 38 by 0.14 equals 5.3 grams palladium from 114 grams MLCCs. The same for platinum. 1% is 38 grams by 0.01 equals 0.38 grams platinum. To calculate the palladium per kilogram capacitors, we divide 5.3 grams on 0.114 kilograms, which gives us 46.5 grams palladium. For platinum, we divide 0.38 grams on 0.114 kilograms, which gives us 3.3 grams platinum per kilogram capacitors. To further purify the button, I put it in a Portland cement cupel. Almost there, just in case I added more lead metal and cupelled the button one more time. Looks better, I think. The only problem I have to deal with are the small beads around the button. The top layer of the cupel will be scraped off together with the beads and smelted with the leads and the solder. XRF analysis of the top and the bottom of the bead. Again some maths, 18.77% from 33.21 grams alloy equals 6.23 grams palladium from 114 grams capacitors, or that's 54.65 grams palladium per kilogram capacitors. 1.59% from 33.21 grams equals 0.53 grams platinum from 114 grams capacitors, or 4.65 grams platinum per kilogram capacitors. And that's not all, I still have to process the leads, the solder and the small beads from the cupel. I put the wires, the solder and the small beads from the cupel in a melting dish. Then I added some litharge, borax, caustic soda, silver and lead metal and begun scorifying. When the scorification process was complete, I poured the molten metal in a cement cupel and continued cupeling. XRF of the button. .3% palladium of 9 grams alloy equals 0.39 grams palladium. And 0.36% platinum of 9 grams alloy equals 0.03 grams platinum. Combined with the other results, 6.23 grams plus 0.39 grams equals 6.62 grams palladium from 114 grams capacitors. Or that's 58 grams palladium per kilogram MLCCs. 0.53 grams plus 0.03 grams equals 0.56 grams platinum from 114 grams capacitors. Or 4.9 grams platinum per kilogram MLCCs. In a nutshell, from 114 grams capacitors I recovered 6.62 grams palladium and 0.56 grams platinum. The calculated yield of the KM6 H90 MO is 58 grams palladium and 4.9 grams platinum per kilogram capacitors.
Thanks for watching. Please don't forget to like, comment and subscribe below.